Good evening, Professor. This is Paul Wiklund for IFT 510, Activity 2, Fall 2020 semester. The assignment was to replicate a Batcher Banyon network and then record my output. As with all things posted to the internet, let's start with the finished product first and run the program. You can see that I receive 8 inputs that are all random binary numbers that output 2 different outputs. To do this, my main contains an array of 8 positions, 4 integers and a data number, and a string array of again 8 positions for the binary conversion. They then run to Batcher, which takes both arrays, and Batcher then calls Banyon, or rather main calls Banyon, which also takes both arrays, and we end with a console.readline so that the window stays open. So in the Batcher, which is thoughtfully arranged to be at top, I have a random method, and that random creates a new random, and we loop 8 times to fill the data number array with 8 random numbers ranging from 0 to 7 to ensure that there are no more than 3 bits. From there, in each loop, I run the binary conversion where the convert to string to take the array position, divide it by 2, and return the remainders. Banyon is then called from the main, and Banyon has the string for data num and the string for binary convert. Those arrays it takes as arguments, and then we create a string called input. We create a string called output, which is an empty string, and we create a string called compare. Within Banyon, I then have a for loop, which runs for the number of elements in the array. So we can change the array size, but we would have to change the amount of bits that we work with. Inside this loop, I have a character pad, and then I create the input. Rather, I declare the input, and I set the value to equal the binary conversion count of where we are in the loop with a pad left. What the pad left does is takes the character pad and puts 0 in all of the blank spaces in the string, because when I ran it without that, I discovered that C# does not account for leading zeros, and so if your element is 0, 0, 1 in binary, it just shows up as 1, and when I looped through I encountered errors because I was encountering a -1. It was searching for a position in the string that didn't exist, so I had to pad the string out with empty characters. So I then run through a switch, and that switch is based off of the count, which is the counter of the loop. I do this to avoid collisions within the network. So case 0 would be the first iteration, case 1 would be the second iteration, case 2 would be the third iteration. And what that does is that sorts according to this. Case 0, case 1, case 2, case 3. So case 0 will call A1, and case 4 will call A1. Case 0 calls A1, case 4 calls A1. All of the A's and the B's and the C's take input, output, and comparison strings. So in case 0 we call A1. A1 takes that input string and does a string.compare ordinal for position 0 and compares position 0 in the compare string. there is only a position 0, so it is the index, and it compares it at the first location. If we have an exact match to 0, then we go to B1. So we would go from A1 at 0 to B1. B1 will then compare if 0 to C1, if 1 to C2. That's the fundamental logic of this. So what I then have is the output, which was our blank string, becomes the input to keep the value of the binary visible, and then it appends it with a statement as to where it goes. So output equals the value of the input plus goes from A1. A1 goes to B1. B1 then takes that same input and compares it at position 1, which is the second, to position 0, the length of 1, to see if it's 0. So same logic, but second position in the binary string. And then appends that. So output equals input goes from A3 to B1, to C1, to whatever my output is over here. Sorry for the missing outputs. This was a screenshot I stole off of YouTube. That was somebody else's face in there. That's essentially it. 110 goes from A1 to B4 to C4 to output 6.